Hello, everyone, and welcome back to the session. We are here to code every Tuesday. We are here, right? Unlocking the potential we have, right? So, here we start. Till now, what we have seen is business understanding, right? What we are doing here is live coding. We are understanding here a project, taking a project. We are considering three products into consideration, three models rather. Uh, that is logistic regression, random forest, and decision tree. We are taking these three models into consideration, and we are making a project, right? So now, till now, uh, we are following, as we discussed, we are following CRISP MLQ methodology, and it's very much important. Now, as a part of it, we have talked about business understanding, various objectives, constraints, success criteria. We talked about data understanding. After that, we imported libraries, right? We imported pandas, numpy, matplotlib, and .pyplot, and cbon. We read CSV, and we loaded the data set. We saw the info. We replaced the any values. We described the same model, right? We described the uh, categorical columns and isnal values. What is the isnal value? Do we have missing values? What are the value counts in income column? Right? All those things we have seen. Now we have visualized the categorical values too. We have seen box plot to see if there are any outlier in the data, and of course there are some columns which we don't consider. So we have seen some columns to remove too, right? We imported Vinserizer, we did Vinserization. Why do we do Vinserization? For outlier treatment. So we treated those outlier, right? After that, we started with pre-processing, right? We saw there's standard scaler, one hot encoder, sklearn.compose has column transformer, simple imputer, pipeline. We have to see everything, right? So we have seen all these things. We have seen numerical pipelines. We have seen categorical pipelines. We have seen preprocessor. We have made a preprocessor that is a column transformer. You drop the income column, and then we see that value counts and all, right? So after that, we started with train test split. We have given the train size, train and test data train size of, we have taken test size of zero point 0.2. This means 20% of the data will be test data and 80% of the data will be train data. After that, we trained the model and talked about model building and evaluation, right? We define, train, and evaluate. First of all, we define this function, train and evaluate. Whether we have model dot fit, we predict the model, we see the accuracy, precision, recall, F1. We have seen all those things. And when we define the function, we get in return accuracy score, precision, recall, and F1 score. We talked about different models then, logistic regression, DT, and random forest, right? We have made a model, we did train and evaluate. And of course, after that, we constructed a data frame to get this as a result. Now, we will today start with hyperparameter tuning. Now, the basic, what are the hyperparameters and why do we need to do hyperparameter tuning? Now, when we talk about it, we always know that there are some parameters in different models. We talk about parameters in models, right? So when we talk about them, of course, every model has different parameters. So those parameters, of course, when we are tuning, these are the hyperparameters that affect a model. These are the hyperparameters that affect a model. Now, what is important is to understand why do we need to do their tuning. Why do we need to do hyperparameter tuning, you may ask? Now, the basic question to answer is, the basic answer to is, to the same, is that when we are making model, a model overfits, a model overfits What is overfitting of a model? We say that the training data or training data we use to train a model, right? And then we evaluate. And when we evaluate on the training data, we get some accuracy, right? Also, in using test data, we evaluate the model. We have the model, the same model that we trained on the training data, we train the model and we evaluate. And then using which we get our accuracy. Of course, in a classification model, we get accuracy, recall, F1 score, all those things. Now, if the trained model, if the accuracy of the model in the training data is high and accuracy of model in test data is low, we say our model is overfitting. Say our model is overfitting. To get over this, to make sure that our model is right fit. Right fit means model's accuracy is high and test data, model on the test data, when we test the model, its accuracy is high too. When the model is overfitting, to make it right fit, what did we do? Or what do? We do hyperparameter tuning. We do hyperparameter tuning. Now remember, this hyperparameter tuning is also called regularization. Regularization, right? So when we're talking about it, let's talk about hyperparameter for different models, right? For example, for logistic regression, we have hyperparameters such as small c, that is regularization strength. Right? And we have, of course, when we have this, we have penalty type. Of course, it's when we talk about penalty type, we have L1, that is lasso, L2, we have ridge, right? Of course, there's elastic net 2. Right. Then we talk about the solver. Solver, when we say solver isn't just an algorithm that is used for optimization. Of course, there are various type of solver we have. For example, we have liblinear, there's Saga, there's LBFGS, and there's Newton CG. Now, other than that, we have Maxitor, there's tolerance, there's class rate. There's so many of them, right? Now, for example, this is logistic regression. Now, next we have is decision tree. Right? In decision tree, of course, we have various parameters or hyperparameters, we call them. When we talk about decision tree, we have various hyperparameters such as maximum depth, right? We have maximum depth, we have minimum sample sleeve, minimum sample split, of course, first of all, we'll see. We have minimum sample leaves, right? Or leaf, we call it. Minimum sample leaf. We have max features. Of course, maximum leaf nodes, impurity decrease, criterion, splitter. There are many, right? Now, the same when we talk about hyperparameters of random forest. So, first of all, random forest is nothing but many decision trees combined, right? So, in random forest, what we say, there are various hyperparameters. Let's talk about random forest here. When we talk about random forest, we talk about various hyperparameters such as number of estimators, number of estimators just gives number of decision trees in random forest. And of course, we will talk about max depth. What is the depth we want? Right? Depth of each tree. Do we want a decision stump? Do we want a proper depth? All these things needs to be considered. Of course, if it's decision tree, a group of decision tree, or a bunch of decision tree, we have minimum sample leaf, minimum sample split, all those things. We have max features, we have bootstrap, we have criterion, leaf nodes, impurity decrease, random state, right? All those things. Random state is something we'll see here. Random state, basically what it does, ensures reproducibility of the data, of the results, right? We have verbose, right? We have warm start, everything. Now, there are many hyperparameters that we are, of course, not writing because of paucity of time. This you must have learned and you will be learning during, or you must have, you will be learning during your regular classes, right? Or you must have learned it during your course or projects, right? So let's talk about the code now, right? We'll go and start coding now. So the first step we talked about, right, is step 4. Step 3 is done. Right? We stored all the output for all three models. Now we talk about is hyperparameter tuning, right? Now we talk about hyperparameter tuning and final evaluation. So first of all, let us take our time to define hyperparameter grid for each model. So we say logistic regression parameter grid. Now, what is this parameter grid? We are just giving everything, every hyperparameter that will be needed here. Logistic parameter grid, and we will take it as a dictionary. We have solver. We have seen this, right? Solver as one of the hyperparameter we say. Of course, small s. Solver we talk about, and it is Newton CG. There's LBFGS, of course, and there is liblinear. right? Now, second hyperparameter we say is C. We have seen that, right? Of course, smaller the C, more is the strength of the same. We say 0.01, right? And we have 0.1, we have 1, and we have 10. Of course, we need to close the bracket. Now, this is the log regression parameter grid. Now, next we talk about is decision tree, right? We say we have decision tree, or I should say decision underscore tree underscore param score grid, right? We are saying again start it. We want max depth. So it is equal to, of course, we need to give a complete list, right? We just can't give it one. So we have none. We are giving 10, we are giving 20, we are giving 30. Right. This is the maximum depth we're talking about. Now, next we talk about is of course minimum sample split. Small m, minimum samples split. Again, we have to give a list. We say 2, 5, 10. Now, when we're talking about it, so always give space, right? Again, why do we need to give space? Isn't it possible to give without space? Of course, it's possible, but it's part of best practices, we know. Minimum sample leaf. Again, we do it as a list 1, 2, 3. Close that. Next we have is random forest. We have random forest parameter grid. And we say n estimators. What is n estimators, you ask? N estimators is nothing but the number. Oh, so sorry. We have to give it as a dictionary. Key value pair, we call it, right? N estimators are nothing but the number of decision tree we want in a random forest. Just copy it from here. Make sure that we cover it in proper given time. So we have parameters such as forest, minimum sample split, we are saying at 2 and 5. And of course, minimum sample leaf, we are saying should be 1 and 2. Now, what we give is a function to perform grid search and return the best estimator. You need to give function to give and to perform grid estimator. And when we say we define the function by def, of course, we have function name perform underscore grid underscore search. And of course, we give the parameters. We say model that we'll be using, that there is param grid that we are talking about, parameter grid, and we say X train, and we say Y train. Right. Now, in that, of course, whenever we define the model, we give colon, enter. Of course, we need to give grid search. We say grid search CV. Grid search CV is again we use for cross validation, hyperparameter tuning, we call it, right? For cross validation, we use grid search CV, and of course, we give estimator equal to model. Param grid equal to param grid. Parameter grid basically, we are saying CV equal to 5. And giving series value equal to 5, of course. Number of jobs to -1. Verbose equal to 2. Scoring equal to F1. Now, we say grid search underscore fit. Sorry, grid search dot fit. We are fitting the model here. We are fitting model on X train and X test. X train and sorry, Y train we give it. X train and Y train. And what do we want it to return? We want it to return grid search dot best score estimator and the score. Say we want to return this grid search underscore estimator. Now let's run this. Oh, so sorry. C. Okay, I'll give in solver. Of course, writing it, I'm not giving commas. Of course, I need to give commas. Syntax. Of course, close the bracket here. I forgot to close the bracket too. Let's run it. Comma. Exactly. Now we run it. Now this is perfect. Now what we go for is to perform research for each and every model. Now we need to perform research for every model. Now we will write best underscore log underscore regression. We say perform grid score search. And of course, we need to give models. First, we will give logistic regression. Of course, we're saying max underscore iter. Thousand. And we want same logarithmic read. Control C. And of course, want X train and Y train. This for first model. And we'll make the same for the next model. We'll just copy the same. Is this paste this? We want for each model, right? So we will see. Even we want decision tree classifier. Decision tree classifier. And we want here random state equal to 42. Now random state, as we discussed, ensures the reproducibility 42. And of course, we have decision tree parameter. We have decision tree parameter grid. Same thing. And of course, you copy this. The complete line, Control C, and we'll paste it here. Control V. So in the place of decision tree, what we want is random forest classifier. We'll see. We will say random state is 42, and we are okay with that. We want, in place of decision tree, we want random forest parameter grid. Then we want X train and X for Y train, right? So now it seems like we are not defined X train. Since we are giving this, we are giving small x, yes. Okay, we are just giving small x train. That will be default. Small train string, so string here. Small x train again. Yes, small x train here too. Run this. Now we need to run this too. It's a CV, it's defined sync. Okay, no issues, team. We'll continue with the same. It's already 1803. It's already half an hour. We'll continue with the same in the next week, right? And today we discuss what is hyperparameter, why do we do hyperparameter tuning, and yes, we'll continue with the error too, right? We will continue with the error. We will solve this error, and we'll come back later, right? Don't worry. Okay, team. I hope you enjoyed today's session. We'll meet the next week for sure. Thank you. Thank you so much for your time.